Hi, welcome to Chapter 1. In Chapter 1, we are going to go through some of the basics of Java and create our very first Java program. So let's get to it. So some of the items that we're going to touch on is basic programming vocabulary. We're going to talk about procedural and object-oriented programming. We're going to compare the two of them. We're then going to dive into the Java programming language and talk about the features available in Java, and then talk about the basics of Java applications. We're going to look at both console and GUI input, and we're going to create, output, and we're going to create a simple program to run with both output types. Most importantly, we're going to talk about commenting and documenting your source code, and then finally, where to find some additional help beyond what we have in the classroom. So let's start with talking about some basic programming vocabulary. Now, this is not Java specific. So a computer program is a set of written instructions that will tell the computer what to do. Okay, computers only understand machine language, which is the most basic level understood by any kind of circuit. So you're talking about electricity, so on and off, binary, ones and zeros. Okay, machine language is considered a low-level programming language. Now, on the opposite side, a high-level programming language typically allows the use of English vocabulary words to put together these instructions, okay? Java is a high-level language. So, in programming, syntax is what is called those specific set of rules used within the language. And we'll see what a syntax error is kind of coming up here in a minute. Program statements are found within the program and can be compared to sentences in the English language. These are the commands that will actually perform the tasks that are going to be required. Since humans use that high-level language and a computer understands a low-level language, a compiler or interpreter is going to be used to translate to get from one to the other. Debugging is the act of finding and correcting any errors within your code. It's a huge part of programming. You can't just program, you have to make sure it runs correctly. And when you do debugging, there are two different types of errors that can be found, okay? You can have a syntax error and a logical error. So remember what we said, a syntax is those rules that make up the language. So a syntax error is going to relate to those rules and sort of violations of those rules, okay? With a syntax error, that compiler or interpreter is not going to be able to complete because it's not going to understand the instructions. Okay, on the other hand, a logic error is going to be a little bit more difficult to find and to correct. The logic error is going to allow the compiler or interpreter to fully complete the compilation, and they're going to be found during runtime. Okay, so an example of a logic error would be if you meant to add 2 to a variable name, except you subtracted 2. Okay, the code is going to run it exactly perfectly. It's going to look like it's doing well, except for the fact that your output is going to be incorrect. So that's why it makes it a little bit more difficult to find. There are 2 types of programs that can be written. The original method of programming back in the day was considered procedural programming. Procedural programming are single statements, all executed in a specific sequence, one right after the other. Okay, all programs are going to contain variables, which are going to be words given to values. Okay, so you can reference that as a variable name. And then object-oriented programming, on the other hand, uses classes. Now, classes are going to be these blueprints for a creation of what we call an object. Okay, these objects are going to be used and implemented by various different parts of your application. Object-oriented programs are most frequently used for simulations and for GUIs. But there are some advantages to using object-oriented programming. Some of them are polymorphism, inheritance, encapsulation. We're going to talk about that in just a minute. So great big words. The idea behind them, it's not as difficult as it sounds. So classes, objects, and encapsulation. We got one of the words in there, right? A class is created to describe a set of objects with common properties. Okay, it needs to have a definition and it has to have an instance. Okay, those are 2 things that are required when you're working with a class. Attributes are going to be characteristics defined within that object. Okay, they're going to be used to differentiate between objects using the same class. okay? The value of those attribute is going to describe the state of the object. That's what we call it, the state of the object. And then an object is a specific concrete instance of a class. So let's take a quick example. Okay, easy peasy. This is, sort of an everyday example. Let's look at a class called dog. Okay, a dog is defined to have attributes of name, age, breed, and shot status. Okay, what that means is all classes of dogs are going to have these specific attributes. Okay, now we can create instances or different objects using that class. Okay, so what it's going to do is it's going to create an object of that class for each one of these 3 dogs. For example, we've got Ginger, Bowser, and Roxy. Okay, so you can see that within those instances, they've defined all those attributes. So Ginger is 6 and she's Nikita and her shots are up to date. Bowser is 2, a retriever, and is up to date, and Roxy is 1 and a beagle, and I don't know why I just assumed they were all female, sorry. Beagle and Roxy is up to date. So you can kind of see how the class and the instance and the definition and the instance kind of all work together. A method is a self-contained block of program code that's going to carry out a specific action. Okay, we can think of it as a procedure. So if we take that dog example we just looked at, we can create a method called sit. We can create a method called stay, or even one called fetch. So the method is going to be an action done by that object. Now, encapsulation. So here's that big word, okay? All that means is that all of the nitty-gritty details are going to be hidden from your user, okay? It's going to conceal all of the little bits and pieces. So if I say fetch, I just mean the dog's going to go get the ball, right? So the little bits and pieces would be like the dog has to stand up, the dog has to find the ball, the dog has to run to the ball, the dog has to open their mouth, bend down, close their mouth around the ball, and then the dog would have to turn around, the dog would have to find me again and then run back to me, okay? I don't care about all those steps. I just want to know that fetch is going to get me the ball, okay? So that's encapsulation. So what encapsulation does is it increases your security, and it's going to avoid inadvertent and accidental changes. So once that method is created and is tested and proven, you don't have to touch that ever again. You can just use that method, and you know that all those nitty-gritties are correct. Now, inheritance on the other side is going to allow the sharing of those attributes and the methods of existing classes, but then you can also add on your own. So like a child would inherit certain traits from a parent, classes can inherit from other classes. Okay, so for example, you could have a class called shape. Okay, then from that you could have a child class called quadrilateral, which means a 4-sided shape, right? And then even you can take it one step further. You can have a child of a quadrilateral and call it a square, which means all 4 sides are equal. So you can see how the inheritance, you always get everything taken from your parent, but you can also add on to it. Polymorphism, again, another big word, but the idea is actually quite simple. It's the term used to describe the ability for that same method or attribute to be interpreted in different situations based on how you're going to use it, okay? Polymorphism, it means it has many different forms. Okay, so just in the basics of the word, you can use them in many different ways in different situations. So those are a bunch of terms and a bunch of vocabulary that are sort of programming generic. So let's move on to Java, because that's what we want to know about. So Java programming language was developed by Sun Microsystems. It was first developed as an object-oriented programming language for general use purpose, okay? So some advantages include increased security. That architecturally neutral basically means it has the ability to run on various platforms. So it can run on Windows, it can run on Unix, it can run on a Mac without any kind of changes that need to be done, okay? It does not execute on the computer directly. That's why it can be ported between operating systems. What it's going to do is it's going to run in this hypothetical universe, okay? And what it's known as is called a Java virtual machine. So the Java virtual machine is started up, and then within that Java virtual machine, that's where the program actually runs. That Java virtual machine is what's going to change per operating system, but not the code. Java uses source code, which is the portion containing all of that high-level language instructions, okay? It's also going to use a development environment. If you watched the previous video about installing the integrated development environments, there are several different, there's a bunch of them out there. They're free, there's paid, there's a bunch. But what it basically is it's a set of tools used to write your programs. Then Java is going to use a compiler, so it's going to convert what you write in your source code into bytecode. It's going to be statements saved in a file, typically converted into machine language or binary so that the computer can understand it and know how to run it. Finally, a Java interpreter is then used to check that bytecode and communicate with the operating system on how to execute those commands. Okay, then it's going to execute those commands within your virtual machine. So let's take a look at this. Typically your Java source code is going to be your high level language file, okay? Then next step down, you're gonna have your compiler, which is gonna be that translator to go from between that high level and that low level, right? Your Java virtual machine is then going to run that low level language file, okay, using a Java interpreter. And then finally, that's what's going to communicate with your operating system. Now, source codes typically have the file extension of a .java, and the bytecode typically has a file extension of a .class. So that's how you can determine the difference between the two. Some notable advantages of the Java language are the concept of write once, run anywhere, and the ability to run either console or windowed applications. Prior to Java, if you wanted a program to run on various operating systems, then the program would have to be written numerous times, okay? Once for each of the different operating system. Java was also one of the first programming languages to support both console output, such as a written text, and we're going to look at both today, and Windows applications with a GUI that include menus and toolbars and dialog boxes. So that's why it makes it very useful and functional. Even the simplest Java application involves a fair amount of syntax. Okay, so we're going to go through what a typical Java application is going to look like. But first, we're going to learn how to create output. So producing output, the line in particular that we're looking at is the system.out.println first Java application, okay? So some things to notice. The phrase first Java application is in double quotes, okay? This is called a literal string. Anything within those double quotes is going to appear exactly how it's typed out onto the screen, okay? Now, that line must be held in some type of format so the computer knows what to do for this task, okay? So let's look at what goes around it. We can also see some of that class hierarchy we talked about before. The actual method is the println. It's pronounced println. That is found in the system class. The system class is the standard device class for whatever operating system that you're using. Okay, now we're going to separate that class from different methods and different other classes by using a dot or a period. Okay, the next word then is out. So what we want is the system standard output. Okay, now let's get back to the method println. After a method, you're always going to have the regular brackets. Okay, within these brackets, you're going to have either one or more arguments. Sometimes you won't have any arguments, but those are going to be the bits of information that the computer is going to need in order to execute that method. So in this case, we're printing to the system output, using the println method, and sending the method the string, the literal string, first Java application. So we know how to do output. Now, in Java, everything must be part of a class and a method. Classes are given names or identifiers. Typically, these classes are going to start with a capital letter, but they can start with any English letter or a letter from another language, an underscore or a $sign, but no numbers, okay? The identifier can contain numbers, though. It just can't start with it. The only other restriction that we have on class identifiers is that it cannot be a Java reserved word, or it cannot be the words true, false, or null, because those are used to actually mean something completely different in the Java language. Some typical conventions of identifiers are that each word of the identifier is capitalized, if there's more than one word put together. Java is case sensitive, so that's something you really need to keep in mind when you're selecting class names, method names, and variable names. Such as the example shown here, undergrad student, 3 different words, all concatenated with each first letter of each word being capitalized, and the same thing with inventory item. The other convention is that it contains something about what's contained in it. So typically the classes are named such that it has some kind of little indicator as to what it is or what it does. Lastly, your class header must include an access specifier. So this is going to specify who has access to it, okay? Typically, it's either going to be public or private. So let's try this in one of our IDEs, and let's see what happens. So for today's lecture, I'm going to use BlueJ as my IDE, and I think maybe for class number 2, I'm going to use Eclipse, just so you get a little different. So when you first open up BlueJ, it should be empty. If it's not, you can do new project, and you can get, let's see, lecture 1. You can choose a location, and it'll say okay. So it's going to give you an empty project. So what you're going to do is you're going to come up here and click on new class. So a class name, we want to call it first because we want to match what is in the lecture. So here we have our first class. If you double click on that, what it's going to do is it's going to open up your first class. Now, BlueJ does give you a bunch of information already there, but what I'm going to do is I'm actually going to delete it so that we're going to start from scratch. So let's look back at our first class. So first we start out with the class header. So it's going to contain the access specifier of public, then the Java keyword class, followed by your identifier of capital F first, okay? After that is a set of curly brackets, and it's going to indent automatically, and I'm going to put the close bracket in there. Okay, anything contained within these brackets is going to be considered the class body. This is where all of your class methods are going to go and where they're going to be held. So now we have our empty class. So that was fun. Here are some words that are reserved in the Java language since they're used for a specific purpose. There's a whole list of them out there. This is just a few. Remember, class names cannot be any of these reserved words. Neither can method names or variable names. Now, here's a list of legal but unconventional and not really recommended class names, okay? So undergrad student. So the convention tells us that we need to capitalize the first letter of each one of those words. So grad and student. It is more difficult to read not having those capital letters. So putting those caps in there makes it more, makes it easier to read. In inventory item, underscores typically not used for classes. Usually they're just removed and the 2 words are put together. And for the last 2, we don't use all uppercase and we don't use all lowercase. Again, start with an uppercase and then finish it off with a lowercase. Now, on the flip side, these are considered errors, okay? You cannot have words with spaces, you cannot use reserved words, you cannot begin with a numeric or a digit, and you can't have any sort of special weird characters. The only one you can have is the $sign. So now we have this empty class hanging out there that we just wrote. So we need to put some information into it in order for it to actually do something. The Java language uses a method named main in order to give the computer a starting place. So there are a few things in the method header. First, again, we have the access identifier, so the main needs to be public. Okay. Next, we have a reserved word of static. This is going to make the method accessible, even though there may not be an instance of this class working. You can always use the main. Okay, so the main becomes a standalone. Next, we have the word void. Sometimes people think that it means that it's not going to do anything, that the actual method is void, but what it actually means is that the method is not returning anything. Okay, so it's returning void. It's returning nothing. So last, we have the method name. And then in parentheses, we have the arguments. Okay, so let's go ahead and add this main method into our empty class. So first we're going to start with the method header of public static void main, and then an open parenthesis. Notice main is lowercase, and then we're going to put the arguments expected are going to go in here. So we're going to do capital string, square bracket, that's not a square bracket, square brackets, there we go. And then we're going to give it the name of args. So in this case, main is going to accept a string array object as its argument. So we're going to put a string with a capital S, the square bracket, and we're going to talk about arrays later on in the course. And then a variable name to identify that argument. Again, just like the class, we're going to have open and close curly brackets at the beginning and at the end of the method. And then everything within that is going to happen in that method needs to be within these curly brackets. Okay? So now our method is created. Now what we want to do within this method is we're going to add that output line in there. So we're going to add system.out.println with no I. So it's PRINTLN, parenthesis, double quote, first Java application. Okay, one new item we haven't talked about yet is the semicolon. So each command in the program needs to have an end of command operator. Java is going to use the semicolon. One of the most common mistakes is missing that semicolon. So make sure you keep your eye out for that. Again, that was fun, right? So in the most basic form, all programs that you write in Java will start out with this much basic information. You're going to have a public class and the public static void main method with the arguments. From there, everything is going to be placed within one of these sets of curly brackets, unless it's a comment, which we'll get to later. But this is what any basic Java program is going to look like. Now, Java ignores whitespace, which is helpful for the human eye. Programmers are going to use whitespace like tabs and spaces and new lines to organize your code and make it more readable. Remember, we're at the high end. We want to be able to read it easily. All parentheses and double quotes are going to have a matching ending to them. Okay, not as important where they are, it's just important that they're there. We're going to use the almond style. That's how I learned, so that's what I'm used to. And it's how my eye has become accustomed to reading in Java code. And really all that means is that we're going to line up our open and close parentheses and we're going to indent after every set of curly brackets. So in order to save our file, we're going to save it with exactly the same name, case and all, as the class name. But we're going to add the file extension .java. This is especially important for your public classes, so let's go ahead and we're going to save our file. Now the nice thing about using the IDEs is that they do save and name classes usually automatically, but you can verify by hitting class save. And then if you open a file window to where you have saved that item, you can see here I have a first.java file. Okay, so now after we save, we're going to need to compile the program. Remember that we're still at the high level, and we need to translate that to get it to that machine code. So we're using an IDE, but you can actually write and compile Java code with a Notepad app and a command line. Once your file is written on a command line prompt, you can just type Java C and the class name. I like to think about Java C as like Java compile, Java with a C. Some things that may occur is that the command is unrecognizable, which means your SE was installed improperly. You may get some syntax errors that are output from your code, or your code is just going to stop. So let's look at an example. First, I'm going to do it from the command line, and then I'm going to go back to the IDE and do it again as well. Okay, so let's compile our code. First, I'm going to do it through the command prompt, and then I'll show you how to do it using BlueJ. So I just typed in the Windows button and typed in CMD, and it brought up a command prompt. Now I made a copy of the file that we had in here, and if I do a directory, you can see there that there is a first.java. So that's what I want to compile. So what I do is I type Java C space first.java. So we've now successfully compiled it. So if I do another dir, you can see there's a first.class, which was created during the compile, and a first.java. Now, let's see what this looks like when I am in BlueJ. So let's get rid of this blank line. So now there's a few things to notice. In BlueJ, when you are in the program view, this shaded portion of the class means that it is uncompiled. Okay, there are two different ways to compile it. You can compile it from your class window using this compile button, or from your project using this compile button. So if you're going to use the one in the project, it's going to compile all the files within that project. This will compile just that one file. So let's go ahead and hit compile. We can see the first thing that happens is that this shaded now goes to a clear. That means that it has compiled successfully. Okay, so that's how you are going to be able to know that it compiles successfully. Now, syntax errors are the errors that the compiler finds during that translation process. Some typical syntax errors are typos, improper installations, missing semicolons, or a bunch of other things. The nice thing about the Java compiler is that it does give an indication as to what that error is. Typically, the error message is going to describe the file name, the line number, and what the error is. Since these errors are happening during the compile, they're considered compile time errors and a violation of the Java language rules, and the compiler stops. So the compiler is going to parse the code or break it up into smaller, more meaningful portions in order to do the translation. The syntax error displayed will give you useful information regarding where to look in your code and what the error is going to be. Just like the compile, you can then run your Java compiled code from both the command line and the IDE. Let's look at both ways. Okay, now let's try to run that class. So let's do it from the command line first. If I just type in Java first, and again, watch the capital letter, it'll actually do the output of the first Java application. So you can do it from the command line. Now let's bring back BlueJ. So to run from BlueJ, go into your project menu and you find your class. You right click on it and you find your main. See, it says new first and new void string. The new main is the one that you want to do. So click on that. Then it's going to ask you for your arguments. We're not going to give it any arguments, so we're going to go ahead and just click OK. Once we click OK, a window is going to come up and it's going to just tell us that first Java application. If you want to modify any of your code, you have to go through all three steps again: writing your code, compiling your code, running your code. Each time a change is done, you have to do all three steps. So let's make a change. So I'm not going to go through how to do both the console and the IDE for the rest of the examples. I just want to let you know that you could do it. So now let's try to modify this Java code. So in order to clear the window, we can do options and clear, and that'll clear out your terminal window. We can close it out. So now let's change this from first Java application to say my new and improved. Go to the end, add a second line, Java application. So some things that you can notice here as well is that once you put the open and close quotes, it will turn that text to a green color, and your reserved words will turn into this brownish kind of color, or the red if you need it. Now, remember we said that if you're going to do any kind of changes, you have to do all three steps. So we updated our code. So then I'm going to save. I want to compile. So remember what we said before, in BlueJ, you've got the hashes, which means it has not been compiled. So this time I'm going to compile it from this right here. So let's hit that compile button. It cleared out, which means it compiled successfully. And let's go ahead and do that third step and run. So we right click, find the void main. We have no arguments, so go ahead and just press the enter key. My new and improved Java application. Now, logic errors, on the other hand, are considered runtime errors. This means that the compiler completes and the error is not found until the code is actually run. They're much more difficult to detect and resolve. There's no indication of the error or where the error needs to be corrected in the code. One way for programmers to improve the readability of your source code is to add program comments. There are multiple ways to add program comments to your code. These comments are going to be completely ignored by your compiler and only benefit the programmer. Okay, some information that can be found are the author, the date, and a brief description of what the class is. We're going to have a specific program comment at the top of each one of our source code files in order for me to help identify which homework or which assignment that you're submitting. Another way to use comments is to comment out a statement. This is usually used for debugging purposes. If you're not sure which command is creating an error, you can comment out lines, which are then going to be ignored by the compiler. Okay, this is going to help you narrow down the location of your errors. There are three main types of comments in Java: a line comment, a block comment, and a Java comment. So a line comment is exactly what it sounds like. It's going to be a double / and it is going to comment out everything until it finds a carriage return. Okay, so it's just going to comment out a single line. Block comments, on the other hand, are going to be a / and an asterisk, and then it does have an ending of an asterisk and a slash. Anything found between those asterisks and slashes is going to be a comment. Okay, you can do multiple lines, you can do multiple sections, you can do multiple pages. So, but anything that's found within those indicators is going to be considered a comment and ignored. Lastly, we have a Java comment. This type of comment is going to behave like a block comment. So you've got your / and an asterisk, but you have a second asterisk. This is going to actually create automatic documentation of your code at compile time. Okay, so that's typically where your Java comments are being used. This example right here, you can see the first line is a line comment with 2 slashes, and then you've got the block with the / single asterisk, and then this asterisk, and then the slash. So let's go ahead and put some comments into our class. Let's go ahead and add some comments. So looking back into the programming assignment requirements, we're going to start with the header. So I'm going to come over here and give myself a little bit of room to groove. If I do the / and then the asterisk to start, I can start a block comment. Now, the things that are required in the headers of your source code files are your name, okay, and then a second line. And the nice thing about BlueJ is that it does kind of, see how it gives you the close. One of the things it does do as well as an indicator is that it puts an asterisk at the beginning of all the comment, even of a block comment. The other thing it does is it kind of grays it out, so you can very easily visually determine that it's a comment. So the name of the file, a description of what the code does, and then any other information that you might need to put in there. Sorry, I have a grumble monkey in my lap. Then any other information. So if you make any assumptions, they might want to go there. If you want to put a date, if you want to put a revision level, all that information can go up there in your block comment. Now, in order to do a single line comment, I can come down here and say I want to comment out that second portion, okay? If I put the /, it turns that portion of the code into a comment. So it'll ignore that portion of the code when it compiles. Again, I've got my hash line, so I'm going to hit compile to clear it out. Right click, main, enter. So I didn't clear my button, so let's try that again. My new and improved, and the Java application is gone. Okay, now everything up till now has been a command line. Okay, so let's create our first GUI output. Okay, now everything up to now has been command line. Let's create our first GUI output. In order to create a GUI, you need to add 2 new lines, okay? So we're going to use something called a JOption pane. This is going to be a basic dialog box, and a dialog box is just going to be a window that pops up that's going to display information. Okay, now a JOption pane is not available in the basic Java installation and the basic Java commands. So in order for our program to utilize a JOption pane, we need to use something called an import statement. It's going to go and get those Java classes and use them for this file. The import statement is going to add additional functionality of that J option pane into our program. For this, we're going to need at the very, very top of our program, under our header comment, it's going to say import javax.swing.j option pane. So we know from before that these are classes, right? It's a JavaX class and a swing class inside of that, and then the J option pane class inside of that, because we have the dots separating it, right? This is called a package. So a package is basically just a easy way of referring to a group of classes. So what we need to add is that J option pane package to our file. Once we import the J option pane, then we can use it. So within our main, we're going to put a J option pane show message dialog, which is going to show the message dialog box, and we're going to give it some text to show. So let's get to it. Now let's try and create our first GUI application. So let's do a new project. Let's call it first dialog. Okay, you can choose location if you would like, and it's going to automatically open your first project, first dialog with the project name. Now, I'm going to put a new class in there. The class name is going to be first dialog, all one word, because remember, our class names have to be all one word. Start with a capital letter. I've got 2 words, so I'm going to make that second word a capital as well. I can open up that first dialog, and it gives me my sort of that shell for you. So what you can do here is you can actually write your name if you want to use what they give you. And you can say first dialogs.java. And as you can see, this is using the Java doc, so I'm going to get rid of that, and I'm just going to leave it as a regular block comment. Okay, and I don't really need the version, so I'm going to get rid of that. Okay, so public class first dialog, it already puts it there for us. We're not going to use any variables, and we just want a main. So let's get rid of all these methods in here because we don't really need them. Okay, now after our header information, remember we said we need to import that J option pane. So that's an import JavaX swing, which typically the swing components are all the GUI components. J, capital O, oops, for option, capital P for pane, and a semicolon after the end. Remember, we always want to put a semicolon at the end, and that import turns to a red to show us that it's a keyword. Now, let's go ahead and put our main method. So public static void main parenthesis string with a capital S, the square brackets, and then args. Okay, open and close bracket. Okay, that looks very, very similar to what we just did using the console as the output. Now, here's where our new stuff's going to come in. We're going to create a J option pane. So OPTION with capital J, capital O for option, pane, dot. Okay, so that's going to call that class. We're going to call the method show message dialog. Oops. D-I-A-L-O-G. Okay, and we know it's a method because it has the regular parentheses afterward. We need a semicolon at the end. So what are we going to send it? First, we're going to send it null, and then we're going to send it what we want it to say. So first Java dialog. Okay, and again, it turns it to green because it is within the closed parenthesis or closed quotes. One of the easy ways to tell if your quotes, if you have matching opening and closing, is to see if I get rid of it, it turns black. If I put it back in, it turns green. Null, again, is a keyword, reserved word, so it's going to turn blue. And these color options are going to be what's going to help you kind of notice your errors going forward. So let's go ahead. We're going to go ahead and compile this. I compiled successfully. Okay, I've got the clean window to go. Void main, right click, click void main. I want no argument, so I'm going to hit OK. So what I get is I get this message box right here, first Java dialog. So you can see the difference between this and the output to the screen. So last but not least, that's all for the programming as far as today goes. So now, where can you find some extra help at? There are places all over the internet, and I'll list some links in the resources to where to find some of these options. The Java API is the main Java class library, has information regarding every class available to Java. It's a very good resource. It's going to give you information like the functionality, what arguments are needed for what methods, what kind of variables are located in objects, how they work. But there's a lot of great information in there. We'll go through it, I'm sure, in the coming up weeks. FAQs can be found on the Java website, and the Java JDK and SDK also has a whole bunch of tools with help in it. Now, some things to remember. We've already been through these, but don't forget. The file name has got to match the class name identically, including case. There are differences between parentheses, brackets, curly brackets, and all of those lovely characters, okay? Don't forget to end your block comments, okay? Using the IDE, it's a little bit easier because there are some color changing that goes on that will help indicate whether it is within a quote or a bracket or a curly bracket. You'll get to see that. Also, don't forget, Java is case sensitive. Don't forget your semicolon at the end of your statement. You must always recompile and run after any changes that you have. And don't panic when you get an error, okay? Your errors are going to give you some really great information about where to find it to correct it. So, and then lastly, don't assume that just because your program compiled that it is perfect and it is correct. Those logical errors are always hidden and you don't see them during compile. Hopefully you've learned some great tools regarding Java and can feel confident that you successfully wrote and ran your first Java program. Congratulations. So next class, we're going to look at different data types and how to use different data types in your programs. Don't forget to watch the case study video and hand it in for credit. And any questions, email me at any time. Until next time, bye.